because multipath is coming. The reception, you need better signal quality to receive. Partly also, so maybe, okay, this is not so,
what do you want?
okay. Maybe for example, this is one path, okay. But because of fading, the next path may be lower. So this one carry to noise, maybe 20 dB, but the next one 18 dB or 6 jet. So you have 3 dB less. So overall, cancel one another. พูดไทยไม่ได้พูดไทยยังมาก
Does mean the ABR may be lower than
Yes.
just only
Yes,
sequence
yes. Maybe you might get 0.5 dB or 1 dB improve, maybe. But it will not be possible to have 3 dB gain, because during the design on the simulation tool, maybe you can see SFN gain, but reception become maybe you gain 3 dB, you become more dB, 2 dB need to receive. So maybe finally you gain 1 dB or 0.5 dB, or maybe finally no gain, because it really depends on the fading profile. Okay, I can explain using this one. So you can imagine you have transmitter number 1. I think if in your notes now maybe okay, this one.
หน้าห้า
Page number 5. So of course, when you have one transmitter and the other transmitter, so then sometimes you have reflection. Also today I read Bangkok Post in somewhere Ramanai or somewhere. You're going to build the highest tower.
ตรงนี้ลำบากตรงนี้
โลประมาณ200 กว่า
ไม่ใช่614
ตรงไหน
ตรงนี้พระราม9นี่แกรนด์รามานาย
อ๋อแกนรามานายยังไม่เสร็จโอเค
นี่ไหมเขายังไม่ตกข่าว
อินเทนยืน
ต้องติดแจมเมื่อกี้นะ
สมัน
ยาวปีหนี
สมันโทรมี
เราดูว่าที่เสร็จแล้ว
building may be better than Bayok to put the
ที่กำลังจะเกิดอะไรสัญญาเนี่ยรู้ที่เขาเสร็จใหม่เกิดสัญญาแล้วโอเค200 กว่า
วันที่14
ใช่โอเค
higher better anyway
higher better because okay you can imagine if this height this signal coming block okay if this height
that means we have to decide antenna pattern to
yes
maybe some เขาเรียกอะไรนะดาวชิว
นาฟิล
if you have some simple simulation tool, normally you can simulate the antenna height. So the height, there is some advantage on that. So this one, 450, not so tall. Next one in Ramanai, there is a tall.
จะสูงที่สุดในโลก
ยันครับ
โอ้600 ยันนะพี่ยัน
ยัน
เป็นโล but 600 many year
160, no,
103 year
2020,
ที่ว่า
year 2020.
20
Yeah, now ready, beginning, just start. 5 years construct.
มันแถวอะไรนะดูไบอ่ะ
Okay, Dubai, that lorry, 20 that. Very confused. So, but you get reflection coming, and then sometimes the measurement become a little bit, more difficult. Also in, I mentioned indoor, because sometimes you have condominium on top, some antenna, but sometimes you just use a small antenna indoor. In Singapore, for the indoor, we have indoor penetration loss about 7 to 10 dB, because many tall building. Also the window is very thick. So this is something to consider, because now many countries will consider indoor portable reception.
this country
Okay.
The
Yeah, also for-
NBTC put this spec.
I think Malaysia is the same.
This indoor minus 10 dB is like
Yes.
indoor or deep indoor.
Okay, in the European standard is 7.3 dB. It's not so heavy. Okay. Probably this 10 dB deeper indoor also includes some height reduction. Okay, because if you have rooftop antenna and then you come down a little bit, height reduced. Also the power, because in Kuala Lumpur we have 6 meter, but sometimes when you have indoor portable, depending if it's you are at ถึง50ถึง20 which floor a little bit different.
นี่เท่าไหร่แน่อีดอ จำกี่เมตร
Okay, so we sometimes I have also have a look at some of the system before we talk about 10. At the moment maybe 5, 6, 7, 8 and so on. Also sometimes it's being used because I think maybe sometimes, especially when you want to have indoor portable, then you cannot use 64 form with higher code. So you use low. So in this scenario, of course, maybe 3 years ago we discussed MPEG 2 or MPEG 4 or something. Now almost everybody go 264 because about 6 months ago in Korea, we tried H.265 for ultra high definition TV. Okay, maybe in ABU also they present
4K
4K mode using our transmitter by KBS in Seoul. They tried. In the future, will you also consider mobile TV? No mobile TV?
Maybe.
เมนที่นะอยู่ที่กสทช
Depends on the MBTC.
NBC
I think it's the same. Also in Singapore, when MediaCorp, before they install the transmitter, they asked me about T2 Lite. Okay, no okay, so on. Also in Myanmar, the same question they asked me. In Malaysia, they want to consider, for example, high definition TV, and then maybe radio for in the same transmitter. That means high definition TV and the radio 2 in 1. So there is 2 possibility. One is use another PLP, maybe PLP number 2, using QPSK. Another choice is using DVB-T2 Lite for this. So there is 2 options, two different configuration for this scenario. So maybe now we have more channels. So before this one, now we have 5, 8. Probably now in Singapore is. We can also see quickly from here. The sound from what we see. We go to okay, maybe we just
หมุนหน่อยเสาอากาศจับไว้ก็ได้เหยียบ
Okay. I think it's
วางไว้บนเก้าอี้
that direction. Okay, so you can see you have now many channels. Service number 1, number 16, 23, 24.
เสาตัวนี้ใส่แบต
อ๋อมีแบตเตอรี่ด้วยครับเป็นแอคทีฟนะ
เป็นแอคทีฟ
อ๋อ
Service number
นี่ปรับ
31.
เกณฑ์ด้วยเหรออ๋อไม่ได้ดูตั้งมุม
อันนี้ดูที
ดูมุมดูอะไร
It's okay.
โอเค
Thank you.
แบตเตอรี่ไม่ใส่
ยังไม่ได้แต่ก็เวลาใช้ก็ใส่เดี๋ยวมันเสียเวลามันเสื่อมน้ำ
พอเสื่อมแล้วเดี๋ยวกัดหมดเลยเอาสายยุ่งเลย
ใช่
ไม่คุ้มนี่
ทันชาร์จก็มีทันชาร์จไม่เน่า
มันไม่แน่เหมือนกันครับบางทีนานๆครับมันจะ
จะทันชั้นนาน
นานกว่าทุกคนครับ
เดี๋ยวนี้ที่บ้านผมเป็นแบบสวิตช์
ของจีนจะเอาเลย
เอาออก
เดือน2 เดือนเรียบร้อย
มันกัดไปยันนู่นเนี่ยแผ่นปิ้นเนี่ย
หมดเลยครับโยนทิ้งเลย
So you can see originally DVB-T2 is quite complex. So you can see finally in the future will you go multiple PLP or no?
not sure
Not sure.
not sure
Maybe for the meantime, I think everybody will go first step single PLP
ตอนนี้เราใช้ซิงเกิลตอนนี้ซิงเกิลอยู่ถ้าซิงเกิลพี
I think single. We have do maybe more than 100 projects in the world. About 50 or more DVB-T2. No multi-PLP, mainly single PLP at the moment. South Africa, Kenya, Nigeria. In Singapore, just now they found, but it is not decided to go multi-PLP. Finally, still single PLP. Okay, but very quickly we can simplify into this method. That so with this, then from here, this is where in some cases, finally when you go to maybe earlier Mr. Hanning mentioned about some SFN gain. There are also some country that have tried MISO in SFN. That means maybe in the SFN you have main and the gap filler. Maybe this one 1, this one 2. The reception is improved by about 2 dB using the MISO. Very often we have some question about 1.3 and 1.1.
2.1
Okay, so you have 1.1 and after that you have 1.2 and then you have 1.3.1, 3 different types. So you can see that using 1.3 ครับผม
เชิญเลยต่างคุณต่างเชิญเลยด้านนี้ก็ได้
Okay, we will continue. ครับผม sorry ครับ my name is Leong คน Malaysia from Singapore. So sometimes they ask what is different 1.3 because maybe in Chiang Mai when we try transmitter 1.3 and then receiver 1.2 is not possible. So the reason is that in 1.3 there is L1 post scrambling. So in Kuala Lumpur at that time still no L1 post scrambling because that was 1.1.1. Okay. 1.1 post scrambling many. So when we have 1.3.1, first you introduce T2 main profile and L1 post scrambling. So because you have 2 profile, one is T2 profile, one is T2 like profile. So in the T2 profile, mainly difference is this one, L1 post scrambling. But in the transmitter, it's just an option. You can turn on or turn off. Because on the set-top box 01 cannot receive. So sometimes you turn off. And then, yeah.
What's it used for? L1 post scrambling.
The L1 post scrambling, firstly the L1 is the layer 1. For example, if I'm the transmitter, Ransan is the receiver. Yes. So first I must tell him my FFT is 32K. my modulation occupancy. No. This is signaling information L1. Okay. So in T2, the L1. So after he know I'm 64 QAM, when we got interval everything, some data is sent. So the data have different constellation than the signaling, because the signaling must be more robust, more strong. So in this case, I will show one slide. This one. This is L1 post scrambling, post signaling information. You can see this one, many. Because we can look in here. We can look in. Is L1. This L1 signal. If it's BPSK, might be like scrambling or scrambling no change.
This means the L1 is BPSK modulation, right?
In the first you have okay, I can change
กว่าเขียนแบบไม่เข้าใจในโลอาซาน
Okay, I change it. This one, oh, very big flip chart. Yes, it's okay. Okay, so I will begin. So first you have this is frequency, and then this is time. Okay. The first symbol, is P1.
P1
So this is the preamble 1. Only 1,000, very few. And then you have P song, but P song have two parts. It has L1 pre, and then L1 post. So then the P song is this one. Okay. Then you have L1 post. So this one only tell what is the FFT, MISO or CISO. Only tell two things. Because there's also DVB-T and T2, because for example in United Kingdom, also all the set-top box normally T and T2 is okay. So this one will help the set-top box to differentiate whether it's a T or T song. Okay. And then you have L1 pre-signaling, which is this one. For example, it carry that interval, PAPR. And then, for example, what is the FFT size? This information is carried inside the L1 pre-signaling. And also, L1 post modulation. Because maybe earlier in the slide I show you L1 post is occupancy, but then you use BPSK. It support BPSK, QPSK, support occupancy, all support. Okay. So and then this one is L1 post. This one only carry the modulation type. For example, whether it is, but it's the PLP. Because we need to support multiple PLP. So sometimes you have many L1 posts if it's multi-PLP. If it's single PLP, only small L1 posts. So you have modulation type and code rate. So for example, QPSK. So the problem about post scrambling before they forgot post L1 post constellation scrambling might be scrambling might be is a problem because if your data is fixed, for example, 60C, so this data is fixed. Is fixed, no change. So after this and data. So this is how the signal is arranged. One frame is 250 millisecond. So if this no post scrambling, maybe the constellation become like this. Because always the data come to here, or maybe you have many zeros. So that is the reason it is no balance, because this one has so many, always come to this point. Here, very few. Because this pattern is fixed. In the PLP data is always changing. So then they try to implement L1 post scrambling. So they use this one. Exclusive OR to randomize. It is mainly a randomizer.
This show the constellation of the L1, right?
Yes, yes, yes.